What if the cities of tomorrow didn't need us to build them? Picture towering skyscrapers rising from the ground without a single human hand involved, streets that repair themselves, and entire urban landscapes designed and maintained by robots. This isn't just a scene from a sci-fi movie. It's a vision that's closer to reality than you might think. Today, we're diving into the fascinating world of future cities built entirely by robots. We'll explore the cutting-edge technologies making this possible, the challenges standing in the way, and whether this bold vision is truly achievable. From robotic construction crews to AI-driven urban planning, we'll uncover what it would take to create a city where humans are no longer the primary builders. So, is this the future of urban living, or is it a dream that's still out of reach? Let's find out together. The evolution of robotics in construction is a story of incremental yet groundbreaking advancements, each step bringing us closer to a world where machines could one day build entire cities. It's easy to think of this as science fiction, but the reality is that robots have already been reshaping the construction industry for years. Take, for example, the rise of 3D printed buildings. What started as experimental projects in labs has now become a viable method for creating everything from small homes to multi-story structures. These machines can layer concrete or other materials with precision, reducing waste and speeding up the construction process. It's not just about efficiency, it's about reimagining what's possible when human hands are no longer the primary builders. But 3D printing is just one piece of the puzzle. Autonomous heavy machinery, like self-driving bulldozers and excavators, has also entered the scene. These robots can operate around the clock, performing tasks that would take human crews days to complete. They're equipped with advanced sensors and AI, allowing them to navigate construction sites, avoid obstacles, and even communicate with other machines. It's like watching a well-coordinated orchestra, except the musicians are robots, and the symphony is a skyscraper rising from the ground. One of the most exciting milestones in this journey was the creation of the first robot-built bridge in the Netherlands. Completed in 2017, this steel structure was entirely fabricated and assembled by robotic arms, showcasing how machines can handle complex engineering tasks with precision. Then there's the use of drones, which have become indispensable for site inspections. These flying robots can survey vast areas in minutes, capturing high-resolution images and data that help engineers identify issues before they become problems. It's a level of oversight that would be nearly impossible for humans to achieve on their own. Yet despite these impressive achievements, the question remains, can robotics scale up to handle the complexity of building entire cities? So far, the technology has proven itself in isolated projects, but constructing a city involves countless interconnected systems, transportation, utilities, housing, and more. Each of these requires not just precision, but also adaptability, creativity, and problem-solving. That's where the real challenge lies. While robots excel at repetitive tasks, they still struggle with the kind of dynamic decision-making that human builders rely on every day. So, while we've come a long way, there's still a significant gap between building a single structure and creating a fully functional urban environment. What does this mean for the future? The progress we've made so far is undeniably exciting, but it's also a reminder that robotics in construction is still a work in progress. The technologies we have today are laying the foundation for what's possible tomorrow, but they're not yet capable of replacing the human element entirely. As we continue to innovate, the key will be finding ways to integrate robotics into the construction process without losing the creativity and ingenuity that only humans can provide. It's not about robots versus humans. It's about how we can work together to build smarter, faster, and more sustainably. And that's a future worth striving for. When we think about the cities of the future, it's easy to picture towering skyscrapers, sleek transportation systems, and bustling streets. But what often goes unnoticed is the invisible force behind it all: artificial intelligence. AI isn't just a tool for constructing buildings. It's the brain that orchestrates the entire urban planning process. Imagine a city where traffic jams are a thing of the past, energy consumption is perfectly balanced with supply, and every neighborhood is designed to maximize both efficiency and quality of life. That's the promise of AI in urban planning. At its core, AI excels at processing massive amounts of data. It can analyze patterns, predict outcomes, and optimize systems in ways that would take humans years to figure out. Take traffic flow, for example. By monitoring real-time data from sensors, cameras, and even smartphones, AI can adjust traffic signals, reroute vehicles, and reduce congestion almost instantly. But it doesn't stop there. AI can also simulate how changes to a city's layout, like adding a new park or removing a highway, will impact everything from air quality to property values. These simulations allow planners to test ideas before committing to them, saving time, money, and resources. Energy management is another area where AI shines. Cities are massive consumers of energy, and predicting demand can be incredibly complex. AI can forecast energy needs based on factors like weather, population density, and even cultural events. This allows cities to optimize their energy grids, reducing waste and ensuring a steady supply. In some cases, AI can even integrate renewable energy sources like solar and wind into the grid more effectively, making cities greener and more sustainable. But as powerful as AI is, it's not without its limitations. Urban planning isn't just about numbers and algorithms, it's about people. A city is more than a collection of buildings and roads. It's a living, breathing ecosystem shaped by culture, history, and human behavior. While AI can analyze data and suggest solutions, it lacks the intuition and creativity that human planners bring to the table. For instance, an AI might propose the most efficient layout for a neighborhood, but it might not consider the emotional impact of tearing down a historic landmark or the social dynamics of a community. So, can AI truly replace human planners? The answer is both yes and no. AI is an incredible tool that can handle the heavy lifting of data analysis and optimization, but it still needs human oversight to ensure that the solutions it proposes are not only efficient, but also humane and culturally sensitive. The future of urban planning likely lies in a partnership between humans and AI, where each complements the other's strengths. Together, they could create cities that are not only smart, but also deeply connected to the people who call them home. This raises an important question. How do we strike the right balance between technology and humanity in urban design? It's a challenge that will shape the cities of tomorrow, and one that requires careful thought and collaboration. After all, the goal isn't just to build smarter cities, it's to build cities that are better for everyone. Picture this: a bustling construction site, but instead of hard hats and human workers, it's filled with self-driving trucks hauling materials, autonomous cranes lifting steel beams, and robotic excavators digging precise foundations, all operating seamlessly without a single coffee break. This isn't science fiction. It's the future of construction, and it's already taking shape. Autonomous construction vehicles are stepping out of the lab and onto real-world job sites, promising to redefine how we build our cities. So how do these machines actually work? At their core, They rely on a combination of advanced sensors, GPS, and artificial intelligence to navigate and perform tasks. LiDAR systems, for example, allow these vehicles to map their surroundings in real time, while AI algorithms help them make split-second decisions to avoid obstacles or adjust their movements. And because they don't get tired, they can work non-stop, drastically speeding up construction timelines. Imagine a skyscraper going up in half the time it normally takes. This is the kind of efficiency these machines are designed to deliver. But it's not all smooth sailing. While autonomous vehicles excel in controlled environments like mines or warehouses, urban construction sites present a whole new set of challenges. Think about it. Cities are dynamic, unpredictable places. Pedestrians, traffic, and even weather conditions can throw unexpected curveballs at these machines. A self-driving crane might handle lifting heavy materials with ease, but what happens when a sudden gust of wind or a stray piece of debris complicates the operation? These are the kinds of real-world variables engineers are racing to solve. And then there's the question of reliability. How do we ensure these machines can handle the complexity of urban construction without constant human oversight? Companies are investing heavily in testing and refining these systems, but the stakes are high. A single error could lead to costly delays or even safety hazards. That's why many experts believe the future will involve a hybrid approach, autonomous machines working alongside human operators who can step in when needed. It's a partnership that combines the precision of technology with the adaptability of human expertise. The potential benefits are hard to ignore. Beyond faster construction, autonomous vehicles could significantly reduce labor costs, making large-scale projects more affordable. They could also improve safety by taking humans out of high-risk tasks, like working at great heights or handling heavy machinery. And let's not forget the environmental angle. These machines can be programmed to operate with maximum fuel efficiency, reducing emissions and contributing to greener construction practices. But as with any groundbreaking technology, there are skeptics. Some worry about the impact on jobs, with fears that autonomous vehicles could replace human workers entirely. Others question whether the technology is ready for prime time, pointing to the occasional glitches and limitations that still exist. These are valid concerns, and they highlight the need for careful planning and regulation as this technology evolves. The truth is, autonomous construction vehicles are still in their early stages, but the progress so far is undeniable. From pilot projects in remote areas to trials in major cities, the groundwork is being laid for a future where robots and humans collaborate to build smarter, faster, and more sustainable cities. It's a vision that's both exciting and challenging, and one that will undoubtedly shape the way we live and work in the decades to come. Imagine a world where entire buildings rise from the ground in a matter of days, not years. A world where construction sites are quieter, cleaner, and far more efficient. This isn't science fiction. It's the reality of 3D printing in construction. This revolutionary technology is reshaping how we think about building, offering a faster, more sustainable way to create structures. But could it go even further, constructing not just individual buildings but entire cities? At its core, 3D printing in construction works much like the desktop printers we use at home, only on a massive scale. Instead of ink, these printers use materials like concrete, metal, or even recycled plastics, layering them precisely to form walls, floors, and roofs. The result? Structures that are not only built at lightning speed, but also with far less waste compared to traditional methods. For example, a 3D printed home can be completed in just 24 hours, using up to 30% less material. That's a staggering leap forward in efficiency. But the real excitement lies in the potential to scale this technology. Already, we've seen entire neighborhoods spring up thanks to 3D printing. In Mexico, a community of 50 3D printed homes was built to provide affordable housing. In Dubai, the world's first 3D printed office building stands as a testament to what's possible. These projects aren't just proof of concept. They're a glimpse into a future where entire cities could be constructed layer by layer. Of course, challenges remain. Scaling up to city-level construction would require advancements in materials, logistics, and even the printers themselves. For instance, current 3D printers are limited by size and mobility, making it difficult to print large, complex structures on site. But researchers are already tackling these hurdles, developing robotic arms that can print in midair and materials that are stronger, lighter, and more adaptable. One of the most promising innovations is the use of AI-driven printers that can adjust their designs in real time, ensuring precision and reducing errors. Combine that with sustainable materials like self-healing concrete or carbon-absorbing composites, and you've got a recipe for urban development that's not just faster, but also greener. So is 3D printing the future of city building? The answer is a resounding maybe. While the technology is still evolving, its potential is undeniable. It offers a way to address pressing global challenges, from housing shortages to climate change, all while redefining what's possible in construction. Whether it's printing a single home or an entire metropolis, one thing is clear: 3D printing is here to stay, and it's changing the game one layer at a time. Picture this: a bustling construction site, but instead of cranes and hard hats, you see thousands of tiny robots moving in perfect harmony, like a colony of ants building an intricate nest. This isn't science fiction. It's the promise of robotic swarms, a groundbreaking approach to construction inspired by the natural world. These systems rely on collective intelligence, where individual robots, though simple on their own, work together to achieve complex tasks far beyond their individual capabilities. It's a concept that could revolutionize how we build and maintain our cities, but how does it actually work? At the heart of robotic swarms is a fascinating principle: collaboration without central control. Unlike traditional construction methods, where a single machine or team directs the process, swarm robotics operates through decentralized decision-making. Each robot follows a set of basic rules, reacting to its environment and the actions of its neighbors. This allows the swarm to adapt dynamically, solving problems as a cohesive unit. For example, if one robot encounters an obstacle, the entire swarm can adjust its behavior in real time, ensuring the project stays on track. The potential applications in city building are staggering. Imagine a swarm of robots repairing a crumbling bridge, with each machine assessing damage, selecting materials, and performing precise repairs, all without human intervention. Or consider a future where swarms assemble entire neighborhoods, laying foundations, erecting walls, and even installing utilities in a fraction of the time it takes today. This isn't just about speed. It's about precision, efficiency, and the ability to tackle projects in hazardous or hard-to-reach areas where human workers might be at risk. But here's the catch: coordinating such a system is incredibly complex. Ensuring seamless collaboration among thousands of robots requires advanced algorithms, robust communication networks, and fail-safes to prevent errors from cascading through the swarm. One misstep, a faulty sensor, a delayed signal, could throw the entire operation into chaos. Researchers are working tirelessly to address these challenges, drawing inspiration from nature's own experts. Bees, ants, and even schools of fish, which have perfected the art of collective behavior over millions of years. The science behind robotic swarms is still evolving, but the possibilities are as vast as they are exciting. Could this be the key to building smarter, more resilient cities? Or will the challenges of coordination and control prove too great to overcome? As we continue to explore this frontier, one thing is clear. The future of construction may not be about building bigger machines, but about working smarter together. Sustainability is at the heart of what makes robot-built cities such an exciting prospect for the future. Imagine a world where every brick laid, every beam installed, and every wire connected is done with absolute precision. No wasted materials, no unnecessary energy use. Robots, guided by advanced AI systems, could ensure that every resource is used efficiently, minimizing environmental impact from the very start. But it doesn't stop there. These cities could be designed to integrate renewable energy sources like solar and wind power seamlessly, creating urban environments that are not just self-sustaining, but actively beneficial to the planet. The environmental benefits are hard to ignore. Robots don't get tired, they don't make mistakes, and they can work around the clock without compromising quality. This means less waste in construction, fewer emissions from machinery, and the ability to recycle materials on site. AI systems could also monitor energy consumption in real time, adjusting lighting, heating, and cooling to match actual needs, rather than relying on outdated, one-size-fits-all solutions. The result? Cities that are not only smarter, but also greener. But let's not get ahead of ourselves. While the potential is enormous, there are challenges that need to be addressed. For one, the production of robots and AI systems themselves requires resources, often rare materials that are mined under less than ideal conditions. There's also the question of energy consumption during the construction phase. Even if the end result is a sustainable city, the process of building it could still leave a significant carbon footprint. And what about the long-term maintenance? Will these systems continue to operate efficiently decades down the line? Or will they require constant upgrades and replacements that could offset their initial benefits? Another angle to consider is the social impact. While robot-built cities might be environmentally friendly, they could also disrupt local economies and labor markets. If construction jobs are automated, what happens to the millions of workers who currently rely on those roles? And how do we ensure that these futuristic cities are accessible to everyone, not just the wealthy? Sustainability isn't just about the environment. It's about creating systems that are fair, inclusive, and resilient for generations to come. So, can robot-built cities truly be a solution to climate change? The answer isn't a simple yes or no. They hold incredible promise, but only if we approach their development thoughtfully, addressing both the environmental and social challenges along the way. The key lies in striking a balance, leveraging the precision and efficiency of robots while ensuring that the benefits are shared equitably. After all, the cities of the future won't just be built for us. They'll be built by us with the help of technology that's as smart as it is sustainable. But let's not get ahead of ourselves. While robots might handle the heavy lifting, literally and figuratively, humans aren't going anywhere. In fact, our role in future cities will shift, not disappear. Think of it like this. Robots are the tools, but humans are the architects, the strategists, and the moral compass. We'll still be the ones designing the blueprints, making critical decisions, and ensuring everything runs smoothly. The key lies in collaboration, a partnership where humans and machines complement each other's strengths. Take human oversight, for example. Robots can process data at lightning speed and perform tasks with precision, but they lack the ability to understand context, ethics, or the nuances of human emotion. That's where we come in. Humans will need to monitor and guide these systems, ensuring they align with our values and priorities. Imagine a robot constructing a building. It can lay bricks perfectly, but it won't know if the design feels welcoming or if it fits the cultural vibe of the neighborhood. That's a job for us. This leads us to the ethical side of things. As robots take on more responsibilities, questions about fairness, safety, and accountability will become even more pressing. Who's responsible if a robotic system makes a mistake? How do we prevent biases from creeping into algorithms that govern city infrastructure? These aren't just technical challenges, they're deeply human ones. Addressing them will require a mix of technical expertise, ethical reasoning, and creative problem-solving. And that brings us to the skills we'll need to thrive in this new era. Working alongside advanced robotics won't just mean knowing how to program or repair machines. It'll also mean developing soft skills like critical thinking, adaptability, and emotional intelligence. After all, the ability to collaborate with machines and with each other will be just as important as understanding the technology itself. Picture a future urban planner who not only designs efficient systems, but also considers how those systems impact the people living in the city. That's the kind of balanced approach we'll need. So, while robots might be the workforce of the future, humans will remain the heart of it. By focusing on collaboration, ethics, and the right mix of skills, we can create cities that are not only smart but also humane, places where technology enhances our lives without overshadowing what makes us uniquely human. And isn't that the kind of future we all want to build? Building cities entirely with robots sounds like a dream straight out of a science fiction novel. But as with any bold vision, there are significant challenges standing in the way. Let's start with the technical side of things. Robots, even the most advanced ones, still have limitations. They're incredible at repetitive tasks, like laying bricks or welding steel, but designing and constructing an entire city requires adaptability, creativity, and problem-solving skills that machines are still catching up to. Imagine trying to program a robot to handle unexpected issues, like a sudden change in terrain or a material shortage. These are the kinds of complexities that human construction teams navigate daily, often without thinking twice. For robots, they're massive hurdles. Then there's the cost. The technology needed to build an entire city autonomously isn't just cutting edge, it's astronomically expensive. From the sensors and algorithms that guide the machines to the energy required to power them, the financial investment is staggering. And that's before we even consider the infrastructure needed to support these robots. We're talking about a network of charging stations, maintenance hubs, and communication systems that can handle the sheer scale of such a project. It's not just about building a city. It's about building the ecosystem that allows robots to build the city. But the challenges don't stop at technology and cost. There are also regulatory and ethical questions to consider. Who's responsible if a robot makes a mistake during construction? How do we ensure these cities meet safety standards when the process is so unlike anything we've done before? And perhaps the most pressing question of all, what happens to the human workforce? Construction is one of the largest industries in the world, employing millions of people. If robots take over, what does that mean for those jobs? It's not just about efficiency. It's about the social and economic ripple effects that come with such a massive shift. And yet, for all these challenges, there's reason to believe they're not insurmountable. History is full of examples where innovation and collaboration broke through seemingly impossible barriers. Think about the first skyscrapers or the early days of the internet. Both faced skepticism and obstacles, but they transformed the way we live. The key here is balance. we'll need to combine the precision and efficiency of robots with the ingenuity and adaptability of humans. It's not about replacing people. It's about creating a partnership where each side complements the other. With the right approach, the challenges of robot-built cities could become stepping stones to a brighter, more sustainable future. What if the cities of tomorrow weren't just designed by humans, but built entirely by robots? While we're not quite there yet, there's one project that's daring to dream big and take the first steps toward this futuristic vision. Let's dive into a fascinating case study that's redefining what's possible in construction and urban development. In the deserts of Saudi Arabia, a bold initiative called NEOM is making headlines. This isn't just another smart city project. It's a vision of a fully automated, sustainable urban environment where robots and advanced AI systems play a central role in construction, maintenance, and even daily operations. NEOM's flagship development, known as The Line, is a zero-carbon city designed to house 9 million people in a futuristic, car-free environment. But what makes this project stand out is its reliance on robotics and automation to bring this vision to life. From autonomous construction vehicles laying foundations to robotic arms assembling modular structures, NEOM is pushing the boundaries of how cities are built. The goal is to minimize human labor in dangerous or repetitive tasks, while maximizing efficiency and precision. For example, drones are being used to survey and map the terrain in real time, ensuring that every inch of the city is optimized for sustainability and functionality. Meanwhile, 3D printing technology is being employed to create building components on-site, reducing waste and speeding up the construction process. But NEOM isn't just about robots building a city, it's about creating a blueprint for the future. The lessons learned here could pave the way for other projects around the world. For instance, by integrating AI into urban planning, NEOM aims to create a city that adapts to its residents' needs in real time, from traffic management to energy distribution. This level of automation and adaptability could revolutionize how we think about urban living. Of course, challenges remain. Building a city entirely by robots is an enormous technical and logistical feat, and NEOM is still in its early stages. Questions about cost, scalability, and the long-term sustainability of such a project are still being explored. But what's clear is that NEOM is a bold experiment, one that could teach us invaluable lessons about the feasibility of robot-built cities in the years to come. So, while we might not have a fully robot-built city just yet, projects like NEOM are showing us what's possible when we combine cutting-edge technology with ambitious vision. It's a glimpse into a future where robots don't just assist in construction, they lead it. And as we continue to innovate, that future might be closer than we think. Picture this: a city where every streetlight, every building, even every piece of infrastructure is constantly communicating, gathering data, and making decisions in real time. This isn't just the future of urban living, it's the foundation of robot-built cities. Big data is the invisible force driving this transformation, acting as the central nervous system that allows cities to adapt, optimize, and even predict the needs of their inhabitants. But what does that really mean, and how does it work? At its core, big data refers to the massive amounts of information collected from countless sources: sensors, cameras, satellites, and even social media. In a robot-built city, this data doesn't just sit idle. It's analyzed, interpreted, and used to make decisions. Think of it like a giant puzzle where every piece of information helps create a clearer picture of how the city functions. Traffic patterns, energy usage, waste management. All of these systems are interconnected and rely on data to operate efficiently. But here, where it gets fascinating. In a city built and maintained by robots, data isn't just a tool, it's the blueprint. Robots use this data to determine where to build, how to optimize space, and even when to repair infrastructure before it fails. Imagine a bridge that can alert robots to cracks in its structure before they become dangerous, or a power grid that adjusts energy distribution based on real-time demand. These aren't just futuristic ideas, they're possibilities that big data makes achievable. Of course, with so much data comes a set of challenges. How do we ensure that the information being collected is accurate and reliable? What happens if a sensor malfunctions or provides incorrect data? And perhaps most importantly, how do we protect this data from cyber threats? After all, a city built on data is only as strong as the systems that secure it. This is where advanced algorithms and artificial intelligence come into play. By cross-referencing multiple data sources and identifying patterns, AI can help filter out errors and ensure the data driving these cities is as precise as possible. At the same time, robust cybersecurity measures will be essential to safeguard sensitive information from hackers or malicious actors. The role of big data in urban development is both exciting and complex. It's not just about building smarter cities. It's about creating systems that are resilient, adaptable, and capable of evolving alongside the needs of their residents. As we move closer to a future where robots play a central role in urban life, the importance of data and how we manage it will only continue to grow. As we marvel at the idea of cities rising from the ground, constructed entirely by robots, it's impossible to ignore the ethical crossroads this vision brings. Who holds the reins when machines are in charge? If a building collapses or a design flaw causes harm, where does the blame lie? With the engineers, the programmers, or the robots themselves? Accountability becomes a tangled web when the line between human oversight and machine autonomy blurs. This isn't just a theoretical debate. It's a pressing question that could shape the future of urban living. And then there's the issue of fairness. Picture this: a city designed and built by robots, optimized for efficiency and cost-effectiveness. Sounds ideal, right? But what happens when that efficiency comes at the expense of equity? Will these robot-built cities cater only to those who can afford the latest technology, leaving others behind? Or worse, could algorithms unintentionally perpetuate biases, creating spaces that favor certain groups while marginalizing others? These aren't just hypothetical scenarios, they're challenges we must confront head-on. Job displacement is another elephant in the room. If robots take over construction, what happens to the millions of workers who depend on these jobs for their livelihoods? While automation can boost productivity, it also risks widening the gap between the skilled and the unskilled, the wealthy and the vulnerable. How do we ensure that the benefits of this technological leap are shared by all, rather than concentrated in the hands of a few? Privacy concerns add another layer to the ethical puzzle. Imagine a city where every brick, every streetlight, every corner is monitored and managed by intelligent systems. While this could lead to safer, more efficient urban environments, it also raises questions about surveillance and data ownership. Who controls the information collected by these systems, and how do we protect citizens from misuse or exploitation? Navigating these dilemmas isn't just about technology, it's about values. It's about making choices that reflect the kind of society we want to live in. Do we prioritize efficiency over equity? Do we embrace automation at the expense of human dignity? These are not easy questions, but they are essential ones. As we stand on the brink of this transformative era, the decisions we make today will echo for generations to come. The future of our cities isn't just in the hands of robots, it's in ours. When we think about building entire cities with robots, the economic implications are impossible to ignore. On one hand, the idea of machines handling construction, maintenance, and even urban planning sounds like a dream come true for efficiency. No more delays due to human error, no more labor disputes, and potentially lower long-term costs. But here's the catch: getting to that point requires a massive upfront investment. The technology needed to make this vision a reality isn't cheap. Advanced AI, robotics, and infrastructure systems would demand billions, if not trillions, of dollars in research, development, and implementation. So, while the promise of reduced labor costs is enticing, we have to ask, who's footing the bill and can they afford it? One of the most significant benefits of a robot-built future is the potential to revolutionize industries. Sure, traditional construction jobs might decline, but new opportunities could emerge in robotics engineering, AI programming, and systems maintenance. Think about it. Someone has to design, build, and repair these machines. This shift could create a whole new wave of high-tech jobs, potentially offsetting the losses in older sectors. But here, the flip side. Not everyone is equipped to step into these roles. The skills gap could widen, leaving many workers behind unless we invest heavily in education and retraining programs. The question then becomes, are we prepared to support that transition, or will it deepen existing inequalities? Then there's the broader economic picture. Cities built by robots could be more efficient, yes, but what happens to the communities that rely on traditional industries? If entire sectors shrink or disappear, entire regions could face economic decline. On the other hand, if we manage this transition well, we could see a surge in productivity and innovation, driving economic growth in ways we can't yet fully predict. It's a delicate balancing act, weighing the potential for progress against the risk of disruption. So, is the economic trade-off worth it? That depends on how we approach it. Done thoughtfully, a robot-built future could be a game changer. Done carelessly, it could leave many behind. The stakes are high, and the decisions we make today will shape the cities of tomorrow. Picture a city where every street, park, and building is designed and constructed not by human hands, but by robots. It's not just about efficiency or speed. It's about reimagining the very fabric of our daily lives. Robot-built cities could fundamentally alter how we live, work, and connect with one another, creating a new urban reality that feels both futuristic and deeply personal. Consider public spaces, for example. In a city shaped by robotics, parks and plazas might be designed with precision to maximize social interaction or promote mental well-being. Robots could analyze data on how people move and gather, crafting spaces that feel intuitive and inviting. Imagine a park bench that adjusts its height based on who's sitting there, or a playground that evolves its layout to suit the kids playing in it. These aren't just conveniences. They're opportunities to rethink how communities come together. But it's not just about the physical design. The way we commute could also be revolutionized. Robot-built cities might feature self-organizing traffic systems, where autonomous vehicles and smart infrastructure work in harmony to eliminate congestion. No more gridlock, no more frustrating delays. Just seamless movement from point A to point B, and with robots handling maintenance. Roads and public transit systems could stay in near-perfect condition, reducing the wear and tear we've come to expect in traditional cities. Of course, there's a flip side to all this innovation. As robots take on more roles in shaping our cities, what happens to the human touch? Will we lose the quirks and imperfections that give cities their unique character? A robot-designed neighborhood might be flawless on paper, But could it ever capture the soul of a place shaped by generations of human creativity and culture? These are the kinds of questions that will define the social and cultural landscape of robot-built cities. And then there's the question of work. If robots are building and maintaining our cities, what does that mean for jobs in construction, urban planning, and maintenance? While automation could free us from mundane tasks, it also raises concerns about economic displacement. How do we ensure that the benefits of robot-built cities are shared equitably, rather than creating new divides? At the same time, there's an exciting opportunity here to create cities that are more inclusive and accessible than ever before. Robots could design infrastructure that accommodates people of all abilities, ensuring that everyone, regardless of age, mobility, or background, can navigate and enjoy urban spaces. It's a chance to build cities that truly work for everyone, not just the privileged few. Ultimately, robot-built cities aren't just a technological marvel, they're a cultural experiment. They challenge us to think about what we value in our communities, how we define progress, and what kind of future we want to create. Will these cities bring us closer together, or will they create new barriers? The answers lie not in the robots themselves, but in how we choose to use them. And that's what makes this vision so fascinating. It's not just about machines, it's about us. Around the world, the dream of robot-built cities is taking shape in fascinatingly different ways, shaped by the unique challenges and opportunities each country faces. Let's start in Japan, where aging infrastructure and a shrinking workforce have made automation not just a luxury, but a necessity. Here, robots aren't just building structures, they're redefining how cities function. From robot-assisted construction sites to AI-driven urban planning systems, Japan is blending its technological prowess with its cultural emphasis on precision and efficiency. Projects like Woven City, a prototype smart city powered by autonomous vehicles and robots, showcase how Japan is using automation to create sustainable, human-centric urban spaces. Next, we head to the United Arab Emirates, where ambition meets innovation on a grand scale. The UAE has long been a pioneer in futuristic architecture, and now it's pushing the boundaries with its vision of robot-built cities. Dubai, for instance, has set a bold goal to have a quarter of its buildings constructed by three-dimensional printing robots by 2030. These robots aren't just building faster, they're building smarter, using advanced materials and designs to create structures that are both resilient and energy efficient. The UAE's approach reflects its desire to position itself as a global leader in innovation, with robots playing a central role in its transformation. Then there's the United States, where the focus is on integrating robotics into existing urban landscapes. Cities like Boston and San Francisco are experimenting with autonomous construction equipment and AI-powered zoning systems to modernize aging infrastructure. The U.S. approach is less about creating entirely new cities and more about upgrading what's already there, using robots to tackle labor shortages and reduce costs. For example, in California, robots are being used to retrofit buildings for earthquake resilience, showcasing how automation can address specific, real-world challenges. What's striking about these examples is how each country's approach reflects its unique priorities. Japan's precision, the UAE's ambition, and the US's pragmatism all offer valuable lessons for the future of urban development. But beyond the technology itself, these projects highlight a shared truth. The cities of tomorrow won't just be built by robots. They'll be shaped by the values and visions of the people who design them. So as we look to the future, the question isn't just how we'll build these cities, but why and what kind of world we want them to create. So, where do we go from here? The future of robot-built cities isn't just a static idea. It's a rapidly evolving field, driven by breakthroughs that are redefining what's possible. One of the most exciting developments is the rise of advanced AI algorithms. These aren't just smarter tools. They're systems capable of learning, adapting, and even predicting the needs of a city in real time. Imagine algorithms that optimize traffic flow before rush hour hits, or adjust energy usage across an entire grid based on weather patterns. It's not just about building cities. It's about creating living, breathing systems that evolve alongside their inhabitants. But it's not just AI pushing the boundaries. New materials are entering the scene, and they're game changers. Think self-healing concrete that repairs its own cracks, or lightweight, ultra-strong alloys that make skyscrapers taller and more resilient than ever. These materials aren't just durable, they're sustainable, designed to reduce waste and energy consumption. And when paired with robotic construction techniques, like 3D printing on a massive scale, the potential is staggering. Entire neighborhoods could be built in weeks, not years, with precision and efficiency that human hands alone could never achieve. Then there's the question of how these technologies will work together. Picture a construction site where drones, autonomous vehicles, and robotic arms operate in perfect harmony, guided by a central AI that coordinates every detail. This isn't science fiction. It's the direction we're heading. The integration of these systems could drastically reduce costs, minimize human error, and even improve safety on job sites. It's a glimpse into a future where cities aren't just built by robots, but designed by them too. Of course, these advancements raise important questions. How do we ensure that these technologies are accessible to all, not just the wealthiest nations? What happens to the millions of workers whose jobs might be transformed or replaced? These challenges are real, but they also present opportunities to rethink how we approach urban development, to create more inclusive systems, and to prepare for a world where technology and humanity coexist in new ways. The future of robot-built cities isn't just about the robots. It's about how we shape that future together. While the idea of robot-built cities might sound like a futuristic dream to some, it's important to recognize that not everyone feels the same way. Public perception is a powerful force, and it can make or break the adoption of groundbreaking technologies. Surveys and studies reveal a fascinating mix of excitement, skepticism, and outright resistance when it comes to the idea of cities constructed entirely by machines. For many, the thought of robots handling everything from laying bricks to designing infrastructure sparks a sense of awe. It's a glimpse into a future where efficiency and precision reach new heights, potentially solving some of the biggest challenges modern cities face, like overcrowding and resource shortages. People who embrace this vision often see it as a way to push humanity forward, freeing up human labor for more creative and meaningful work. But not everyone is on board. Skeptics worry about the loss of jobs, the potential for errors in robotic systems, and the ethical implications of handing over so much control to machines. Interviews with everyday people reveal concerns about whether these cities would feel human enough. Would they have the charm, the imperfections, and the cultural richness that make cities feel alive? And then there's the fear of the unknown. What happens if the robots malfunction, or if the systems are hacked? Surveys also highlight another critical factor: trust. For widespread acceptance, people need to believe that robot-built cities are safe, reliable, and built with their best interests in mind. This isn't just about the technology itself, it's about how it's communicated. Transparency, education, and clear demonstrations of success will be key to winning over those who are hesitant. So what will it take to bridge this gap between excitement and skepticism? It starts with addressing these concerns head-on, showcasing successful pilot projects, involving communities in the planning process, and ensuring that the benefits, like lower costs, faster construction, and smarter urban design, are accessible to everyone. The future of robot-built cities isn't just about advanced technology, it's about building trust, one brick at a time. As we step into the realm of robot-built cities, one critical question emerges. Who makes the rules? The idea of cities constructed entirely by machines isn't just a technological challenge, it's a legal and ethical puzzle that demands entirely new frameworks. Right now, our current laws are built around human labor, human decision-making, and human accountability. But when robots take the lead, how do we ensure safety, fairness, and responsibility? Let's start with the basics. Right now, most construction regulations are designed to protect workers, ensure structural integrity, and safeguard the public. But when robots are the ones welding beams, laying foundations, and assembling buildings, those rules need a complete overhaul. For instance, how do we certify a robot's ability to follow safety protocols? Who's responsible if a robotic crane malfunctions and causes damage? These aren't hypothetical questions. They're real hurdles that governments and policymakers will need to tackle head-on. One of the biggest challenges is striking the right balance between innovation and public interest. On one hand, we want to encourage technological progress and the incredible efficiencies that robots can bring. On the other, we can't let innovation outpace accountability. Imagine a scenario where a robot-built skyscraper develops structural issues years later. Who's liable? The company that designed the robots, the engineers who programmed them, or the government that approved the project? These are the kinds of questions that keep regulators up at night. And then there's the issue of fairness. If robots take over construction jobs, what happens to the millions of workers who rely on those jobs for their livelihoods? Governments will need to create policies that not only regulate robotic construction, but also address the societal impacts. This could mean everything from retraining programs for displaced workers to new taxes on companies that use robotic labor to fund social safety nets. The good news, we're not starting from scratch. Some countries are already experimenting with frameworks for autonomous technologies. For example, self-driving cars have forced governments to rethink traffic laws, insurance policies, and liability standards. These early steps could serve as a blueprint for regulating robot-built cities. But cities are far more complex than cars, so the solutions will need to be equally sophisticated. Ultimately, the goal is to create a system that fosters innovation while protecting people. It's a delicate dance, but one that's absolutely necessary if we want to build the cities of the future responsibly. The rules we create today will shape the world we live in tomorrow, so we'd better get them right. As we step into an era where robots are increasingly shaping our cities, one question looms large. What happens to the human workforce? The rise of automated construction and urban planning doesn't just change how we build, it reshapes the very skills we need to thrive. This shift isn't about replacing humans, it's about redefining their roles. And that starts with education and workforce development. The first step in preparing for this robot-built future is recognizing the demand for new skill sets. Robotics engineering, artificial intelligence programming, and even advanced data analysis are no longer niche specialties. They're becoming the foundation of modern work. Think of it like this. If robots are the builders, humans are the architects, the problem solvers, and the innovators who guide them. It's not just about understanding how to operate machinery. It's about knowing how to design, maintain, and improve these systems. But here's the challenge. Our current education systems weren't built with this future in mind. Many schools still focus on traditional trades and career paths, which, while valuable, may not fully prepare students for the technological demands ahead. That's why there's a growing push to integrate STEM, science, technology, engineering, and math, into curricula at every level. From coding classes in elementary schools to advanced robotics labs in universities, education is evolving to meet the needs of a world where robots are key players. And it's not just about technical skills. Soft skills like creativity, critical thinking, and adaptability are becoming just as important. After all, robots excel at following instructions, but they don't yet possess the human ability to think outside the box or navigate complex social dynamics. These are the areas where humans will continue to shine, and education systems must nurture these abilities alongside technical training. For those already in the workforce, the transition may feel daunting, but it's far from impossible. Upskilling and programs are emerging as vital tools for helping workers adapt. Imagine a construction worker learning to oversee robotic teams or an urban planner mastering AI-driven design tools. These opportunities not only secure jobs, but also open doors to new, exciting career paths. The key takeaway: a robot-built future doesn't mean a human-less one. It means a future where humans and robots work together, each bringing their unique strengths to the table. By investing in education and workforce development today, we're not just preparing for this future, we're shaping it. And that's a future worth building. As we marvel at the possibilities of robot-built cities, one critical question emerges. How do we ensure these futuristic urban spaces are not just innovative, but also safe and secure? After all, with advanced technology comes new vulnerabilities. Imagine a city where every aspect of infrastructure, transportation, energy, water systems, is controlled by interconnected robotic systems. Now, imagine a single cyber attack disrupting that delicate balance. The risks are real, and they demand serious attention. One of the most pressing concerns is cybersecurity. In a city run by robots, every system is connected through networks, making it a potential target for hackers. A breach could lead to chaos, traffic lights malfunctioning, power grids failing, or even entire buildings becoming inaccessible. To counter this, cities would need robust cybersecurity measures, such as advanced encryption, real-time threat detection, and constant system updates. But even these defenses aren't foolproof. That's why redundancy is key. Building multiple layers of security ensures that if one layer fails, others can step in to prevent disaster. Another challenge lies in system reliability. Robots, no matter how advanced, are not immune to malfunctions. A single glitch in a construction robot could delay critical projects, while a software bug in a maintenance bot might lead to safety hazards. To mitigate these risks, engineers would need to design systems with built-in fail-safes and regular maintenance protocols. Think of it like an orchestra. Each robot is an instrument, and if one goes out of tune, the entire performance suffers. That's why constant monitoring and quick response mechanisms are essential to keep everything running smoothly. But it's not just about technology. Human oversight plays a crucial role too. Even in a city built by robots, people will need to oversee operations, troubleshoot issues, and make decisions when systems falter. This creates a unique partnership between humans and machines, where each complements the other's strengths. For example, while robots might handle repetitive tasks with precision, humans can step in to address unexpected challenges that require creativity and adaptability. Of course, safety extends beyond technology and oversight. It's also about designing cities with resilience in mind. What happens in the event of a natural disaster, like an earthquake or flood? robot-built cities would need to incorporate disaster-resistant architecture and emergency response systems that can adapt to rapidly changing conditions. Picture a city where drones and robots work together to assess damage, reroute traffic, and provide aid in real time. It's a vision that combines innovation with practicality, ensuring that these cities are not only futuristic, but also prepared for the unexpected. So, while the idea of robot-built cities is undeniably exciting, it's clear that safety and security must remain at the forefront of this revolution. By addressing these challenges head-on, we can create urban spaces that are not just smart, but also resilient, reliable, and ready for the future. The question is, are we prepared to take on the responsibility that comes with such ambitious innovation as we wrap up this exploration of robot-built cities? It's clear that this concept sits at the intersection of ambition and practicality. On one hand, the advancements in robotics, artificial intelligence, and construction automation are nothing short of groundbreaking. Robots capable of laying bricks, assembling structures, and even managing entire construction sites are no longer the stuff of science fiction. They're here, and they're evolving rapidly. But on the other hand, the road to fully automated cities is paved with challenges that go far beyond just technology. Think about it, building a city isn't just about stacking materials or programming machines. It's about creating spaces where people live, work, and thrive. That means addressing questions of affordability, accessibility, and sustainability. Who gets to live in these robot-built cities? How do we ensure they're designed with human needs in mind? And what happens to the millions of workers whose jobs might be transformed or replaced by this shift? These aren't just technical hurdles. They're deeply human questions that demand thoughtful answers. And then there's the ethical dimension. Handing over the reins of city building to machines raises concerns about accountability and control. What safeguards do we need to ensure these systems are transparent and fair? How do we prevent unintended consequences, like environmental harm or social inequality? These are complex issues, but they're also opportunities, chances to rethink how we design and inhabit the world around us. So where does this leave us? The vision of robot-built cities is undeniably compelling, but it's not a foregone conclusion. Whether it becomes reality depends on our ability to balance innovation with responsibility, to dream big while staying grounded in the needs of people and the planet. It's a challenge that calls for collaboration across industries, disciplines, and borders. And it's a conversation that's just beginning. What's your take on all of this? Do you see robot-built cities as an inevitable part of our future, or do you think they'll remain a fascinating but distant idea? Drop your thoughts in the comments below. We'd love to hear your perspective. And if you've enjoyed this deep dive into the world of futuristic technology, don't forget to hit that subscribe button for more thought-provoking content. Thanks for watching, and we'll see you in the next video.